In this video, we're going to model a set of data with a linear function. In order to do this, we're going to be writing a linear function for each situation described. Second, we're going to set the functions equal to each other. And last, we're going to solve the new equation and use it for graphing purposes. For this example, we'll be determining when costs are the same. So if costs are the same, they must be equal to each other. We have the Hertz Car Rental Agency charging $25 daily plus 15 cents per mile. So Hertz is going to charge $25 daily plus 15 cents per mile. That translates to 0.15 multiplied by M for number of miles. Now we've got the budget rental car agency, and they charge $20 daily plus 25 cents per mile. So that 25 cents per mile translates to 0.25 multiplied by M, which represents miles. So what we want to do is first come up with the individual charges. For Hertz, I'll just write H. Their cost is a function of the miles you drive the car. So cost is a function of miles. It is 15 cents per mile added to $25 daily. So that describes the total cost for the Hertz rental car agency. Now we're going to look at budget. Budget charges 25 cents per mile and $20 per day. So there are the two functions. Now question 1 says to find the daily mileage for which the budget charge for the day is the same. That means when it is equal to that of Hertz. So we're going to set these two functions equal to each other and solve for M. That would be 0.15 M plus 25 equals 0.25 M plus 20. So I need to collect my variables on one side of the equation and collect the constant terms on the opposite side. So using our properties of equality, I'll take away 0.25 M from each side. That will leave me negative 0.1 M plus 25 equals 20. Subtracting 25 from each side, I'll have negative 0.1 M equals negative 5. Now don't worry about the negatives because in our next step they will be eliminated because I'm going to divide by a negative 0.1 on each side of the equation. Now that gives us M equals 50. M, remember, is miles. So this translates as when you travel 50 miles, the cost for car rental would be exactly the same for Hertz and budget. In order to graph this linear function, we actually have two linear functions that we're graphing, and we'll graph them both on this Cartesian coordinate system at the same time. So it's very much like what we did back when we talked about systems of linear equations. So I'm going to construct two different tables here, one for Hertz and one for budget. So we're going to have the number of miles and the cost. It would be very helpful if we could determine the y-intercept for each of these linear functions. So that means the input, or mileage in this case, would be 0. So I'm going to go back to Hertz and find C of 0. So when I let the M value equal 0, you can see that first term is eliminated and 25 is the output. So we'll have the y-intercept of 0, 25. Now I'm going to do the same thing, but this time use the budget function. So I'll code that back in red. 0.25 times 0 plus 20. Here again, that first term eliminates and I'm left with 20. So 0, 20 is the y-intercept for budget. Now looking back to M equals 50 miles, that is supposed to represent at 50 miles the cost is the same, but we don't know what that cost is. We could find out by using 50 as the input value for both of these functions. So I'm going to substitute 50 back over here in the table and make that calculation now. So C of 50 For Hertz, that represents 0.15 times 50, add 25. So 0.15 multiplied by 50 is going to give us 7.5 added to 25, so that's 32.5. Now if I go back to the budget cost function and substitute 50, that would be 0.25 times 50, add 20. So 0.25 times 50 gives us 12.5 added to 20, and we still have 32.5. So algebraically, we just proved that these two functions have the same input and output values. So when we graph these lines, they really should intersect at this common point. So let's set up our graph. Input was miles. Only positive numbers would make sense for miles. And cost, you're going to be charged to rent the car. So again, positive numbers. So we want our mileage to be along this bottom axis, and the cost will be here on this edge of the axis. So I can go ahead and get those set up. Now we've labeled each axis with its variable, but we also need a title. So we need distance in miles, and our output is going to be total cost in dollars. The next thing we need to do is come up with an appropriate scale. Now our input in mileage needs to go as high as 50. So I'll skip every other line and count by fives. Our total cost in dollars, our smallest value is 20. Largest is 32.5. Here, smallest value is 25. Largest is 32.5. So I'll count by twos. Remember, you're always starting with 0. So don't make any gaps when you're making your scale. I'll start with Hertz, and since I wrote that function in blue, I'll make that line blue on my graph. I'll plot 0.25. Then I'm going to plot 50 and 32.5. When I draw this line, I'm going to use an arrow on the right-hand side because it's possible to travel more than 50 miles, but on the left side, it's not going to be possible to go negative miles. Now, let's plot our ordered pairs for budget. The y-intercept for budget was 0.20, and our common point at 50, 32.5. Again, I need a line that has an arrow at one end. What's interesting to notice from the graph now is that initially budget was charging less money than Hertz, but once you go beyond this 50 miles, budget is actually going to be charging more money than Hertz. So I hope you found this helpful.